All right, everybody, day 7 distance learning. Hopefully you enjoyed the video that I put up earlier about why athletes train at higher elevations. I just wanted to give you just a mini recap. I know some of you are kind of worrisome about how you would do in physics or things like that, but you would do great. Physics is really important because physics is really what governs all the other sciences. So if you can understand physics, you can understand any science. So let's just kind of look at the physical mechanics, the physics of breathing. So after today, you should be able to explain the reasoning behind why athletes should train at higher elevations or do train at higher elevations, provide an analogy to relate breathing and atmospheric pressure. And I'll just give you a scenario so you'll have that. All right, so pulmonary ventilation, remember pulmonary has anything to do with the lungs. There's 2 phases, right? Inspiration, which is gases flowing into your lungs, and expiration, which is gases flowing out, okay? It relies on a pressure difference between the atmosphere, this outside, and the alveoli, the inside, right? So the image that I put here, I just want you to kind of look. So the one on the left, we're looking at inhalation, okay? So what's happening? So our diaphragm is moving down and our intercostal muscles are causing our rib cage to move out. So when that happens, we're increasing the space cavity of our chest, right? And so what's that doing is we're increasing the space, which decreases the pressure. Okay, so we're increasing the volume, decreasing the pressure, which allows air to naturally flow in. Okay, that's why you don't breathe like, like that, unless you really want to. When we look at expiration or exhaling, we're seeing that now we're getting a contraction of the diaphragm muscle. So the diaphragm is moving up, right? We're actually getting that inward movement of our chest. And so that's making our chest cavity smaller. And so what's doing that is it's causing that pressure to increase. When that pressure is increasing because the space is smaller, the volume is smaller, then we're naturally pushing air out. That's why if you like bend over or something, you kind of are naturally pushing out because you're just kind of making that chest cavity smaller, that volume area. So this is something called Boyle's Law. I'm not going to get into Boyle's Law. I mean, we could spend all day talking about it, but basically what this is the relationship between pressure and volume of a fixed quantity of gas in a closed container. I'll explain why closed container is so important later. So we're looking at pressure and volume, and they're inversely related. Okay, so that means if pressure increases, or let's say, okay, if volume increases, the pressure decreases, right? If volume decreases, then the pressure increases. So they're inversely related. They're oppositely, if that's ordered, related. All right, again, just trying to visualize this. So each of these diagrams that you're seeing, they have the same molecules, okay? What's happening though is that in this closed chamber that you can see here, because these are closed because they have lids, this one has a lot more space, okay? Because it has more space, there's less pressure. And then you can think about it in terms of like collision of these particles. These particles aren't going to collide as much. Once you decrease this volume, you get the same amount of particles in a smaller space. You're increasing the likelihood that they're going to collide. So basically, you're increasing the pressure. Okay? All right. So an analogy that I want to give you is, let's say you are, I don't know, going to go to Big Bear or Mammoth or something like that for the weekend. You decide that you're going to pack chips. So this is what your chips look like at the beginning of your trip. Here are your chips, okay? You get to Mammoth or Big Bear, which is at a higher elevation than where we are, and your chips now look like this. No. I didn't mean you go from nacho cheese to sour cream and onion chips. I mean the bag. I'm talking about the bag, okay? So all of a sudden your bag is super, super inflated. And some of you might have experienced this where your bag might even pop. Okay, so why does that happen? Okay, well, this bag, I want you to notice, both of these bags are closed, hence closed container. And so the molecules in the bag, when we start, let's say at sea level, are going to be a certain amount. Once we get into a higher elevation, okay, we're changing the pressure that exists. Okay, so there's less atmospheric pressure. So now that there's less atmospheric pressure, it's allowing the force of the molecules on the bag is exerting on the outside, let's say, to expand that bag. Okay, it doesn't mean that all of a sudden, oh my gosh, now you're going to end up with more chips. It's just that now we have a lower pressure, which is allowing that to expand. Same idea of if you've ever flown anywhere for a long period of time. Let's say, I don't know, you flew to France for whatever. But if you've been on a plane and you've come off and you've ever felt like, hey, my hand feels really puffy, I feel kind of bloated and swollen, that's weird, my shoes are really tight and they're fine. It's because of this lower pressure, okay? Because what's occurring is the pressure is changing, and then now the pressure that your body is exerting is higher than what's being exerted on you. So again, I just wanted to give you that as a little scenario. You can relate this. Now, if you're wondering, why does the bag have to be closed? Because think about it this way. If the bag were open, just using this model, right, the molecules would be able to escape, meaning that the area isn't a confined space. It isn't a closed system. It's an open system where molecules can go in and out freely. Okay, so that's why that occurs. Again, if you had an open bag of chips or cookies or something like that, you're not going to experience this. But if you do take something that is closed, you will experience something like that. So I just wanted to give you a little recap. Basically, our bodies exert force and pressure, and force and pressure is being exerted around us as well. So again, we're at sea level for the most part, so we're pretty much even, right? And it really only changes if we go into those higher altitudes or elevations. And just to understand that pressure and volume are inversely related. So larger volume, less pressure. Smaller volume, higher pressure, right? That's what it means. And just so that you know, you can do physics, right? It's all around us, and I think you would do great. So I hope this helped a little bit. Have a great rest of your day, and I will see you all later.